Algebraic is area and algebra, but it's magical. It's wonderful. You've got any problems with algebra as one of those flag words, you join us. Introducing algebra, understanding algebra, and really importantly, overcoming both the fear and the confusion that exists around algebra.
What we're doing is a puzzle. It's fun. It's just like doing any puzzle. And what you've got to do is you've got 10 little pieces there, and 2 blue and 3 green, and the other we'll call peach. I don't know. It's a funny color. There are 5 of them. And the puzzle is to fit them in to the big outline on top, the frame there. So they all fit in neatly. And you've got to join them edge to edge. And X can be anything. That's just why we call it X. So it can be bigger than 1, it can be smaller than 1, but in this case it looks bigger than 1, because what you see is the small green squares are 1 unit by 1 unit. If you've got a square that's 1 unit by 1 unit, its area is 1 square unit. There's bigger squares, they're in blue, and they're X units by X units are the measurements of the edges, and therefore the area of the blue squares is X squared square units. And we've got the peach pieces, they're rectangles, and so that they will match. The shorter edge matches to the unit square, because it's length 1 unit, and the longer edge matches to the blue square, because that's length X units.
It's like the X factor. We don't know who's going to win. All that the X is we don't know its length, and it doesn't matter what the length is. It's just different. Yeah,
exactly. And it's a gateway into algebra. So what we're doing is linking multiplication, because you multiply the lengths of the edges, to area. So you get the area of the shape by if it's a rectangle, by multiplying the length by the breadth. And then we link that. Then we will link that to algebra, and we'll do that later in this hour. What we do with the children, and it's fun for adults, families can do it, parents can do it with the children, is to print out the sheet. And we'll tell you about the link to, perhaps Caroline can get it to go along the footer of this, the link to the Aiming High website, and there you'll find an inclusion and home learning guide. And this will give you a sheet that you can print out, and you can, and then you can do the puzzle for yourself. So what you do is you cut out the 10 pieces, and then you put them into the big rectangle, and that's as we said, that's it. And then we ask the learners, children, to draw other shapes which are not rectangular, but by just putting these pieces together so that the X's match the X's and the units match the units, and write down the areas that they get. We're going to move on to think about this process of linking multiplication to area to algebra. But just a bit of a diversion first is we got to know what these brackets mean, because we're going to use brackets. And how do we do the arithmetic of adding and subtracting and multiplying and dividing? And when we put brackets into this list of numbers, what do the brackets mean? And there's a little sort of word that is often used. Think about it. You may have met it in a slightly different form.
So it's had a BODMAS, haven't they? Most people.
Well, I don't like BODMAS. I means index, which is power. What does O mean, Caroline?
It's orders.
I think BIDMAS is better than BODMAS. But anyway, what we want to do now is to match the expressions on the left with the values on the right. Can we work out what we've got here? So why don't you do the top one, Caroline, and see which of the ones under the values column it matches to.
Okay. just done 7 plus 2, which is 9. And then I multiply that by 5 plus 3, which is 8. So it's 9 eighths. So it's 72.
That's it.
That's on there,
okay.
yeah.
And the next one is 9 times 5, which is 45, plus 3, which is 48.
Yeah.
What's the next one, Caroline?
So the next one is the key operation is in the center, 2 times 5, which is 10, and then you're adding on another 10, so that's 20.
And the bottom one, you've got your 5 added to 3, which is 8. So you're doing your brackets first, and then you multiply by the 2, which is 2 times 8, which is 16. And then 16 adds 7 is your 23. Now, Caroline mentioned the power of the picture. I like that, Caroline. Now here, if you remember, we were talking earlier about having those 10 pieces and fitting them into the frame. And here you've got the solution. We've got ourselves quite a long way into algebra just by matching these, putting these pieces together in this way. And the bridge was the idea of multiplication, because when you do purely numbers, you're multiplying how many there are in each row by how many there are in each column, and that gives you the number of units, and that's your area, the square units. Here you've got your 10 pieces and they go together, and you can see that 2x plus 3 is times x plus 1 gives you 2x squared, and the 2x and 3x make 5x, and then you've got the 3, and we've put them in the 3 different colors. So we've got something really neat there that takes us from just a simple puzzle, and it takes us into something quite complicated, which is this multiplication of the 2 expressions, each of which have got in brackets, in the 2 brackets, each of which have got 2 terms. And the first term in the first bracket is 2x plus 3 in the first bracket.
And there's your 3.
You've got 2x times x, which gives you your 2x squared. And that's the blue area, in which is the rectangle in the solution, which is 2x times x. And then you've got 2x times 1, which is the area on top of the blue, 2x times 1. You're doing 2x times x, which is 2x squared, and 2x times 1, which is 2x. And then, this is the algebraic process, they do 3 times x plus 1. So they do, first of all, 2x times x plus 1, and then it's 3 times x plus 1, which is on the left, which is your 3 times x, which is your 3 peach pieces, area 3x square units, and then 3 times 1, which is your 3 green squares. And finally, you put the 2 pieces in the middle together, because they're all the peach pieces, giving you 5x. So you've got 2x squared plus 5x plus 3. So you move from the pictures right back now into the top right-hand part of my screen, and you see what you're doing is multiplying your 2 binomials. Now, why is this conservation of area written there? You see, when the children are doing the puzzle well, all along really, but from the very early age when they're solving this puzzle, it's just fitting these pieces into this big frame, what they're doing is realizing they're not stretching those pieces, and however you separate it into little bits or put the little bits together again, you are keeping the same area. You're conserving it, as we mathematicians call it. So what we're doing is we have to understand in the mathematics that we're not changing the area, and we are not changing what the maths tells us when we piece it together and we pull it apart and we piece it together again. So quite a lot of manipulating those letters and numbers in algebra. And that's what you're doing. If you just look at the box at the top now, this is pure algebra. All you're doing is putting the pieces together as you did in the jigsaw puzzle. You mustn't move on until people really understand what's happening. And often this multiplying of the two binomials, these two brackets together, is taught as these are the rules, this is how you do it. And if you do it the right way, you'll get the right answer. And the children really don't understand it, and then they don't remember what the right way was. And algebra then becomes something that's confusing and difficult. And as they go on doing more of it, they just get into deeper and deeper water. So what we're trying to tell you here is that the best way to get your head around algebra is to make sure that every step on the way you actually understand what you're doing. And here what we've done is to make this process of multiplying the two binomials together, and we're breaking it down into the little pieces, putting the pieces together again in a puzzle, and then seeing how the areas fit and why you get the result of 2x squared plus 5x plus 3 at the end of the game. We've got the two blue squares, which are the 2x squareds in area, and we've got the 5 peach colored, and that's the 5x in area, and we've got the 3 little green ones, each of them 1 unit, so they make up 1 unit, 3 units of area. And so we've got 2x plus 3 times x plus 1 is 2x squared plus 5x plus 3. Now, what are these key questions? They're really important, because what we do, a good teacher does, is to give the children activities, give the learners activities to do, and then to build on what they're actually doing, their own activities. So can they make a rectangle with the 10 pieces? That's another way of asking them to fit them in the frame you just saw. Just make them into a rectangle. Maybe that's a simpler thing to ask them to do. And can you subdivide the rectangle into 4 simpler subunits and find the areas? 4 simpler, a subunit is part of a bigger unit, and find the 4 areas, the areas of the 4 parts of it. You've made some different shapes using the 10 pieces. Do you notice anything about the areas? And what you want is that the areas are always going to be 2x squared plus 5x plus 3. However you move them round, the total area is going to be 2x squared, 2 blue ones, plus 5x, 5 peach ones, plus 3, which is the 3 green ones. And I think then we should be reinforcing these ideas by going back a step and doing it with something that's more concrete, if you like, more. They've been working with the numbers for many years before they reach the algebra. So let's go back and do it with the numbers. And here we have with the numbers 34 and 28. 34 times 28. And this is what people call long multiplication. And this is a great way to do multiplication. So we've got the tens and the units. We've got the 30 is 3 tens and 4. 34 is 3 tens and 4 units. 28 is 20, 2 tens and 8 units. The whole process of arithmetic is based on what we call place value. And the long multiplication, this shows so beautifully how long multiplication is broken down into simpler steps.
it takes the mystery completely away from all. They take this and carry one, and why am I putting that one there, and what am I adding again? Just takes that whole mystery away and just makes total sense. So you've got 20 30s, you've got 30 of something, and there's 20 boxes of those. Well, how many have you got? It's a lot more than, certainly not 60.
So what you've got to think about there is this 30 in a row going across, if the other units, right? And there's 20 rows. So how many units are there altogether? 30 by 20 is your 600. And then you've got 4 in a row in the thin strip. And you've got 20 rows. So how many altogether? 4 times 20 is 80. And when you come down to the 8 of the 28, you've still got to multiply it by 30. And there's 30 in a row, but there's only 8 rows now. So that's 240 more units. And then 8 by 4, there's 4 in a row, and there's 8 rows. So you've got 32 units there. So we're looking at tens and units, and we can imagine breaking the tens down into units as well. And that takes all the mystery out of long multiplication.
Yeah.
Isn't that nice? So now let's jump back into algebra. And doesn't the algebra seem simple now? You see, algebra, the reason we use these P's and Q's on X's and Y's and R's and S's and then other letters too, is that we're dealing with something that we want to be what we call a variable. We want it to be changing. And as it changes, things are happening that we can think about, and we can learn a lot from watching the algebra change, watching the variables change. And one place we actually watch them change is in the graphs. So imagine in your minds now, you've seen graphs, seen also different graphs in different places. And as you move across your picture, we usually call that the X direction. Things are changing as X changes. And as you move up and down, we usually call that the Y direction, and the Y is changing up and down. So the graph is your all-in-one picture of how things change as you change X and as you change Y, or as you change them both together. And, well, your graph could be a straight line. It could be a nice curve of a parabola, like the shape that you get if you throw a ball in the air. That's a parabola. And you can have other graphs. You can have statistical graphs too. Same thing. Your statistical graph might be some going across is the date, right? And it's as the dates change, as you go through the weeks, as the dates change. And on the graph that goes up and down, that could be something about the number of cases of coronavirus or something. But as you see, the shape of the graph now isn't, well, you hope to see it going down. Well, let's come back to number 5. Supposing you need to multiply P plus Q by R plus S, and P and Q are our magic variables from which we can find out so much when we study them a bit further. That's why algebra is so useful. It's why maths is so useful in many hundreds of thousands of applications, millions of applications. So it's all because of the power of variables. So P, Q, R, and S are variables. So it doesn't matter at the moment what we're just having to fix them to draw a diagram. But we're going to multiply P plus Q by R plus S. And the same way as we multiplied 34 by 28, we do the same thing again. And in our diagram here, think about rows and columns. we've got P in a row, P whatever they are in units in the row, and R row, so the area is PR, and below it you've got the area of SP.
So PR meaning P times R. You just don't have to put the times table. That's the way it's done.
Yes, yes. So that the whole thing looks prettier. You don't put the multiplication sign in, because you know that whenever you have these two letters in algebra together, then without anything between them, it means that they're multiplied. And then you've got a rectangle which measures R by Q, R one way and R up and down, and Q right and left. And when you work out that area, it's RQ. And you've got another one which measures Q across still, but now it's S up and down. And that rectangle is, if you want its area, you multiply S by Q. So what we've done here, we've linked the whole idea of multiplying and in rows and columns, and then we've linked it to area to find how many you've got all together. We had a marching band and people in a picture last week of people in a marching band, remember that? And that we counted how many rows, how many in a row, and then how many rows there were. And that is a quick way to work out how many people all together, not counting them, don't need to count them one by one. And you're doing the same thing in algebra. Now we think about a key question, is what we were asking before. But if we say to the class now, they've done a lot of examples, and now we say to the class, suppose you need to multiply those two expressions in the brackets. They're called binomial expressions, bi meaning two things in the bracket. Show me what you would draw to find four areas that give you the product of the two expressions. So when you multiply one thing by another, you get a product. You will see that is a key question, in the sense that if they can answer it and do it as we did the other examples, the learners will show you that they really understand this process. And that is what's important. Not that they can actually do it and get the right answer, because a machine can do it quicker and doesn't make mistakes. That is not what you want to teach children, just to be able to do something, turn a handle, do something by a sort of rote method and get an answer. Because in this modern world, that's not valued anymore. Machines do that. What do people do? They have to be creative with the ideas. They have to be able to apply the ideas and use the machines to actually do the working out. Okay, so now the next step was, what might we need this for? Well, this is a very, very sort of simple little example, but here we're going to be thinking about solving a quadratic equation. So what we're told is the area of the rectangle is 66 square meters, and you've got to find x. You might have been asked it in a completely different way and given x and been asked to find the area. But this question is sort of turned on its head, and you're given the area and you're asked to find x. Now here, this is such an easy problem, we can guess the answer, because we've got the area of that rectangle is 3x plus 2 times x plus 3, but it's 66, we're told. So how can we break 66 up into two factors? Well, it can be 2 times 33, or 3 times 20, or 6 times 11. Well, we know it's more than 3 because we've got one side is x plus 3. And so what about 6 times 11? Well, if x plus 3 is 6, that gives us x is 3. And 3 times 3 plus 2 is 11. Oh my goodness! So if we substitute x equals 3, we've solved it. We've found the length x, and it all works beautifully. Now suppose it was a more difficult quadratic, and we couldn't guess the factors, and we couldn't find x just by guesswork like that. Then we'd have to solve the equation. And on this slide, you see written line by line in great detail how to solve the equation. Right, let's wind up then, Caroline. We've had a journey, haven't we?
The Amy High website is where you get all these resources,
and it's all free. All free, no charge. but it isn't free insofar as a huge amount of time and effort goes into it. We have a team of people working who are actually doing empowering teachers who teach in the poorest of the poor areas in Africa, where they've got living conditions are not good, but people are very cheerful and they don't complain a lot, and that's what I find. And what we want is the children to be able to get a good job when they grow up and maybe have a chance of a better life. And so what I do, and my team, AIMSEC, does, is to try to give the children a better life. Because they get a better education, we empower the teachers to give a better education by training the teachers, by helping the teachers. And that is where we're looking for donations, because we have, but to do it, we have to spend some money. A lot of people are working for nothing, right? Nothing.
Yeah.
But there are we have got a team of people in South Africa who we have to employ in order to make it all possible. And physically at the moment, there are 90 teachers on the course, and it's a 3-month course. It's all online, and we're asking for people to donate. So a lot of people are benefiting from all the free resources, and we hope that they will appreciate that they're getting something for nothing, and they could give something back by helping us a little. You don't have to give a lot of money. If you've got a lot of money to give, that would be fantastic. But even if everybody who uses our resources gave us a little bit of money, it would add up to something which would help us a lot.
Thank you so much, everyone. For greater understanding and enjoyment of mathematics, the Maths Toys YouTube channel is brought to you by AIMSEC and the Aiming High website. In the description, you will find a link to our home learning guide for ages 4 to 18 and a teacher resource pack. If you find this video useful, there is a GoFundMe link in the description to donate to and support AIMSEC. The money goes to bursaries for professional development for teachers in disadvantaged communities around the world. Subscribe, comment and ding the notification bell to make sure you don't miss our latest activities.